more examples left from section 2, part 1. All right, so part H says 2 cosine squared x minus 5 sine of x plus 1. So if you notice, when you look at this one, we actually don't have all of them in terms of sine or all of them in terms of cosine, right? So we need to change things. So what we're going to do is a little trick. We are going to change cosine squared into something that it's equivalent to. So we know that sine squared plus cosine squared is equal to 1, right? So if I just have cosine squared, what can I replace it with?
1 minus sine squared.
Yeah, 1 minus sine squared. So I'm going to do that. So I'm going to have 2 times 1 minus sine squared x minus 5 sine of x plus 1 equals 0. So I get 2 minus 2 sine squared x minus 5 sine of x plus 1 is equal to 0. I don't like that it's negative, so I'm going to do a little, I'm going to divide by a negative first. So I'm going to divide by the negative, and I get positive 2 sine squared x, positive 5 sine of x. And then I originally had 2 plus 1, which was 3, so I'm going to have minus 3 equals 0. And then I factor. So when I factor, I need 2 sine of x times sine of x, and then I write cosine. And then I know my signs have to be opposite each other, and I need a positive 5. So I'm going to put a 3 on the end and a 1 on the inside. I need the positive 6 and a negative 1 to combine to be positive 5. So when I do that, I have two equations. So I'm going to have sine of x is equal to 1/2, and I have sine of x is equal to negative 3. So I told you guys yesterday, if you ever get sine of x equals 4, or sine of x equals negative 5, or something like that, sine of x is always between negative 1 and 1. So when you get sine of x is equal to negative 3, that is not giving you a solution. You can cross it out. All right, so if I have sine of x is equal to 1/2, that is here and here, I get 2 solutions. So I have x equals pi over 6 and 5 pi over 6. Those are my 2 solutions. Okay. So that one involved a substitution, right? We changed cosine squared into 1 minus sine squared, factoring, we eliminated the one that didn't work, and so on. It was a long question. All right, so we pull out a tangent x, which is its GCF, and we set it equal to 0, so we have tangent of x equals 0, and we have tangent of x equals 1. So if tangent is equal to 1, we know that there are 2 locations in the unit circle where our x and y values are exactly the same thing. All right, so our x values and y values are the same in the first quadrant and also the third quadrant, right there. We don't do second and fourth because it's like root 2 over 2 and then root 2 over 2, but one's positive, one's negative. Okay, so I get x equals pi over 4 and 5 pi over 4. And then when tangent is equal to 0, that means that the sine is equal to 0, right? Because it's sine of x over cosine of x. So the sine value is equal to 0. So sine is equal to 0 in 2 locations, here and here. So we also have 0 and pi. Good. All right, now J. J is a little bit harder.
Miss Conn, sorry, on that one, I don't understand how you got the tangent of x minus 1. Like on the first
I pulled out a GCF. So see how I have tangent squared minus tangent x. Yep. So I pulled out a GCF. Okay, so let's try sine of 2x equals root 3 over 2. I'll put it on this page. All right, this involves what we call a W substitution. So what we're going to do is we're going to let W equal 2x, and we're going to find it on the interval. Instead of 0 to 2 pi, we're going to go from 0 to 4 pi. We're going to double the interval. So what we're thinking of is when is sine of W equal to root 3 over 2? Okay, so we know sine is equal to root 3 over 2 in 2 different locations. So we would get W equals pi over 3 and 2 pi over 3. But since we're going to 4 pi, we're going to go all the way around the circle again. All right, so if I was at pi over 3 and I add 2 pi to it to go all the way around again, what would I be at? 7 pi over 3, because we're adding 6 pi over 3, right? So we're also going to have 7 pi over 3, and if I add 6 pi over 3 to the next one, 8 pi over 3. So the reason we do that is because W is really 2x. So we have pi over 3, 2 pi over 3, and so on, dot, dot, dot. So when I divide by 2 everywhere, my answers will now be on the interval 0 to 2 pi. So if I doubled the interval and then halved it again, then I'm back on 0 to 2 pi. So I'm going to have pi over 6. If I take 2 pi over 3 and I divide by 2, I'm going to have pi over 3. I have 7 pi over 3 divided by 2 is 7 pi over 6. And 8 pi over 3 divided by 2 is 4 pi over 3. Those are my 4 answers. Those out for the notes. So we took all of this and we divided by 2. All right, do you guys remember those now? All right, I'm going on. So let's do, whoops, cosine of 3x equals negative 1/2. So if I have cosine of 3x equals negative 1/2, all right, now I'm going to do the w substitution. So I'm going to write cosine of w equals negative 1/2. But now I'm going to go on 0 to 6 pi for w. So you're going to have a lot of answers. So if I have cosine is equal to negative 1/2, that is in 2 locations. So I'm going to have w is equal to 2 pi over 3 and 4 pi over 3. But I'm going to go around the circle 1 time and then around the circle again. So I'm going to add 2 pi to each answer. So see how that's the same as adding 6 over 3 pi? Oops, that was not pretty. So if I add 6 pi over 3, right, same as 2 pi, I get 8 pi over 3 and 10 pi over 3. And then I'm going to add it to these ones as well. So I get 14 pi over 3 and, where was I? 16 pi over 3. That's what your w is equal to, and w was 3x. And what we're going to do is we're going to divide all of our answers by 3. So usually it's just multiplying by 1/3, right? It's changing all the denominators. Yeah, Katie?
So what are you adding by to get to those?
I'm adding 2 pi to this, and then I'm adding 2 pi to this and this. So that represents 3 times around the circle. All right, so I have 2 pi over 9, 4 pi over 9, 8 pi over 9, 10 pi over 9, 14 pi over 9, and 16 pi over 9. So fun, right? Writing tiny. Are you guys writing tiny? You do have additional notes in the back if you ever need to flip. All right, and let's do the very last one. So on this one, we have 4 cosine squared of 2x equals 3, or minus 3. So I'm going to add the 3 over. So I'm going to have 3/4 cosine squared of 2x. So when I take the square root, I get cosine of 2x equals plus or minus root 3 over 2, right? Square root of 3 over square root of 4, root 3 over 2. So again, it's a w substitution. So I'll just write solve with w. Do we need to finish that one? You guys get the gist of that?